We are now going to focus on rational numbers, specifically proportions and scales. We will not have a fit bin for this video, but please make sure you know the terms and the content that we are going to cover. A proportion is an equation stating that two ratios are equal. We're going to compare these two ratios. Now you can see in the illustration or the example at the bottom, we have 24 over 3. That's one fraction. Now remember, I can actually write that one fraction two different ways. I can write it with a colon, 24 to 3, or I can write it out the way I'm saying it. I can write it out 24 is to 3. Now that fraction, that proportion, is going to be compared, that fraction is going to be compared and equal to 24 over 3 is going to be equal to 16 over 2. So this is going to be an equal proportion. So two equal ratios form a proportion. Okay, let's test this out. Are the two ratios equal? Okay, we have 24 over 3 and 16 over 2. Well, what I can do is I can find a greatest common factor. 24 and 3. Now, I'm not going to be doing the same greatest common factor for both fractions, but I'm going to try and simplify 24 over 3, and I get 8 over 1 because I found the greatest common factor for the numerator and denominator was 3 to get 8 and 1. Now, 16 over 2, the greatest common factor, is 2. So I can divide that also and get 8 over 1. So yes, the two ratios are equal. Now, this is something we did in class in which we are going to be identifying the extremes and the means. Now, the extremes and the means are basically identifying cross multiplication. So A and D are the extremes, they're getting crossed. B and C are the means, they're getting crossed. So what we focus on class, just like if we want to find a missing number, such as n or x, we have to cross multiply. So we did this very briefly in class, so let's build on that. Now the product of the extremes is equal to the product of the means. What does that mean? When I cross multiply, A and D will equal B and C. Okay, here's a little example. 3 over 5, or 3 to 5, is equal to 3 to n. 12 to n. So I need to cross multiply this. I need to multiply 3 times n and then 5 times 12. Now when I get 3 times n, okay, I can't really do anything. But when I cross multiply 5 times 12, I get 60. But I'm not done yet. I need to isolate n. So that means I need to divide n by, or 3n by 3 to get it by itself. Now if I do it on one side, I have to do it also on the other side with that same number. So I divide 3n by 3 and I get n, but then I also have to divide 60 by 3 and I get 20. So n equals 20. So 3, okay, to 5 is proportional to 12 over 20. Now let's take a look at the examples. All you have to do here is kind of show your work. You're going to cross multiply and you're going to identify, is it proportional or not proportional? And we're going to use a little equal sign for proportional, and then we're going to use a little equal sign with a little line through it saying it's not proportional. So let's cross multiply 3 times 16, 8 times 6, and we get 48 equals 48. Okay, that's proportional. And then when we do example 2, 2 times 10 is 20, but 7 times 3 is 21. Okay, that is not proportional. Okay, and you can see the 20 with a little equal and kind of line through it to 21. It is not proportional. Now I'm going to give you some more little practice problems. Let's see if you can do these on your own. all you're doing is cross multiplying and writing, is it proportional or not proportional? Okay, go ahead and pause the video. Okay, hopefully you cross multiplied. 8 times 3 is 24, and 6 times 4 is 24. That would be proportional. And then 5 times 18 is going to be 90. And then 16 times 6 is 96. So that is not proportional. Now, when we focus on a scale drawing is basically a little drawing, like a little blueprint that, or identifying or showing that all ratios of lengths in the drawing make up actual lengths. So the blueprint in the picture down below is using centimeters. Now that's an awful tiny house. Well, no, the house isn't really that tiny. It's actually going to be in a simplified form of actual measurements. So the actual measurements, if I'm using centimeters, then the actual measurements, well, if I'm using centimeters in the blueprint, the actual measurements are going to be in meters. If I'm if I'm using inches in the blueprint, the actual measurements are going to probably be in feet. Okay, here are 2 examples. I want you to pause this and see if you can identify the approximate distance and the dimensions of the house in example 1 and 2. Now, keep in mind that the scale, okay, 1 inch to 50 miles is a fraction. That's going to be a proportion, a comparison. So we're going to keep this as a fraction, not across from each other, but as a fraction. So 1 inch over 50 would be the fraction, and I'm comparing this with, okay, 5 inches over my missing number. So please cross multiply to figure out what the missing number would be. And then when you do example 2, remember 48 feet by 42 feet, okay, they are not over each other. Okay, that would not be a fraction. That is a comparison. Here we have the dimensions of the floor plan of 8 inches over or by 7 inches. So what I need to do is compare 48 with 8 and then 42 with 7. Okay, so let's see how we do here. So n is going to be 250 miles. Why? Because n times 1 is n. Okay, and then I don't have to divide or get it by itself. It's already by itself. And 50 times 5 is 250. So 1 inch, okay, is to 50 miles. So if he traveled 5 inches, okay, he went 250 miles in reality, actually. Okay, let's take a look at the dimensions of the house. 48 feet. It should be 8 over 48 because 8 inches to 48. And then we would be looking at 7 over 42. So what's the scale used in the drawing? So if I have 8 over 48, it would be, okay, find my greatest common factor, 1 over 6. Make sure you always add your units, 1 inch over 6 feet. Okay, let's try these practice problems. Okay, a 35 kilometer distance is 5 centimeters on a map. Okay, find the scale. Okay, this is pretty easy. I'm just turning this into a fraction, right? Or 5 centimeters to 35 kilometers. But don't forget, I want to simplify this. So we have 5 is to 35, okay? But the focus here is I need to simplify. Is there a greatest common factor here? Yes, 5 can go into both. So I can break this down to 1 centimeter equals 35 kilometers, or 1 centimeter equals 7 kilometers because 5 goes into both. Okay, 1 centimeter equals 7 kilometers. Okay, here's another practice problem. Okay, 8 is to 64. Can I find the greatest common factor? Yes, I know 8 goes into both. So 1, okay, inch equals or is proportional to 8 feet. Now here's a little tricky one here. We have a 4-foot table. It's 4 inches long. Okay, what is the scale used? So 4 inches to 14 feet. That would be, we find the greatest common factor. Now 4 can't go into both of these, but 2 can. So I can break this down into 2 inches equals 7 feet. Well, you know what I can also do? I could go a little further. If I want to bring this down, it's not going to make this big old decimal, but if I divide my 2 inches, which equals 7 feet, if I divide both by 2, it would give me 1 inch equals 3.5 or 3.5 feet. And that's not too bad. So I can actually break this down even further. Okay, if you have any questions, please reach out to me